Hello all, welcome to this new lesson. In the previous lesson, I showed you a very simple C program to add to integer values. And in this lesson, I'm going to show you a very simple program to add to floating point values. Okay, so if you have not watched my previous lesson, then I would highly recommend you to please go watch that video before going ahead with this lesson. Okay, so assuming that you have watched my previous lesson, I'm just explaining this program as quickly as possible. Okay, so as I've discussed in my previous lesson, the first line, which starts with a forward slash star mark and that ends with a star mark and a forward slash, is called as a comment line. Okay, so what is the use of comment line? Comment lines are used for documentation purpose, isn't it? So in my example, I've just documented to the one who is actually reading this program, whoever it might be, right? Whoever sees this code will understand that this program is all about adding to floating point values, right? So comment lines are ignored by the compiler. Okay, so these lines are not part of your executable, right? So this is the first line, and coming to the next line, this line is called as your preprocessor directive. This is called as your preprocessor directive. Preprocessor directive. Okay, so the role of preprocessor directive is to include the contents of this header file stdio.h as part of this program. Okay, so as explained in the previous video, stdio.h contains some standard function prototypes for the function printf that we have used in this program, right? So if suppose we do not add this line hash include stdio.h, the compiler may issue a warning, or sometimes it might even go ahead and give us a error, right? So it doesn't allow us to compile this program, right? So it says there is a missing function declaration. So that is the reason we have to add this preprocessor directive by saying hash include stdio.h, right? So by adding this line, we get the function prototype for this printf function as part of this program, right? That is the second line. And as usual, every C program must definitely contain this main function, which acts as the entry point into your C program. That is, the CPU will start executing your C program, assuming that main to be the entry point, right? So your program execution starts with your main function, right? And it takes the form int main, open the parenthesis and close the parenthesis, and open the brace and close the brace, right? So open the brace and close the brace actually indicates a block where we can actually write a set of statements to accomplish certain tasks, right? So because this open brace and close brace is associated with main function, okay, so we can call this as the mains function block, right? So people who are very new to programming and who don't understand these terms called as functions and function prototypes, please don't worry, I'm going to discuss this in detail in an upcoming lesson. Okay, so there's a separate chapter called as functions, where I will be discussing all these function declarations, functions, function definitions, and everything related to functions would be declared, would be clearly explained in that particular video lesson. Okay, for now just understand and just go with the flow, right? Now coming to the next line, so we have a line called as variable declaration. This is called as declaration, or more specifically variable declaration. Okay, so what does this line do? This line indicates the compiler to allocate memory location for three variables, or simply telling this line allocates or creates three variables named a, b, and sum. Okay, so how much of memory has to be allocated for each of these variables is informed by the data type. So in our program we have the data type as float. So float data type is used to represent floating point constants, and if suppose we create any variable using the float data type, the amount of memory allocated for each variable would be of 4 bytes, right? So here in our example, the variable a will occupy 4 bytes, the variable b will occupy 4 bytes, and variable sum will occupy 4 bytes, right? So this is called as variable declaration, or sometimes it is called as variable definition too, because of memory being allocated along with the declaration, right? So this is this understood. Now coming to the next two lines, these two lines are called as assignment statements. Okay, let me write it. Assignment statements, because we are assigning the value 6.5 into the variable a, and we are assigning another value 5.5 into the variable b. As you can see, 6.5f and 5.5f are called as floating point constants. So therefore the variable a will contain 6.5 and the variable b will contain 5.5. Okay, so these are the two values for the variables a and b. Now in the next line, this is called as an expression, okay, where we are adding the values of a and b, right? So plus is an arithmetic operator, and I'm going to discuss about arithmetic operator in detail in an upcoming lesson called as operators. Okay, so for now, just understand that plus is used for adding the values that are stored in variables a and b. After adding these two values, I store the value or the result into another variable sum. Okay, because after adding these two values a and b, I get again a resulting floating point value, which is nothing but 12.0 or something like that. Okay, so which I will have to store it into a variable sum, and therefore that is the reason I have declared even sum as the variable sum to be a floating point variable, right? So now after adding 6.5 and 5.5, I get the result as 12.0, which gets stored into sum. Okay, and then finally, after finding the result, I'll have to print the result on the screen, and for that we make use of the standard built-in function called as printf, right? So we know that printf is a standard library function which is used to print certain characters on the screen, and it needs a string as the first parameter for it. Okay, and all the set of characters that are part of this pair of double quotes, okay, will get printed on the screen until it matches in a closing double quote, right? So first of all, once it enters into this double quote, it starts printing all the characters that it sees. Okay, so first, so the output would be S U M. It sees space, even space is a character, so space gets outputted. Okay, then O, then F, and again it sees a space, so space gets printed on the screen. And the moment it encounters a format specifier, right? So it doesn't get printed as it is, rather it goes to the other part of the double quotes, fetches the value that is there in A. We know that in our example, A is of type floating point. That is the reason we have used the format specifier %f. If you remember in the previous program, we were printing integer, and the format specifier to print an integer is %d. Right, so because here we are making use of floating point value, so we will have to use the format specifier as %f. Okay, so the value of A will get replaced in place of %f, so it becomes 6.5 followed by zeros. Okay, 1 2 3 4 1 2 3 4 5 6. Okay, 6 digits, right? And then again it continues printing the rest of the characters. So it starts from here. Okay, and again it encounters a format specifier. The moment it encounters the format specifier, it goes to the other part of the double quotes, fetches the value of B, and it replaces in place of %f. So B value is again a floating point constant. It's a floating point variable. Okay, therefore that is the reason we have included this format specifier %f. Okay, and so in place of %f, what gets printed is B's value, which is nothing but 5.5. So 5.512345, right? So there would be 6 digits after decimal point, right? And then again it continues printing. Then it says is. Okay, is again, right? And then again we encounter a format specifier. Therefore it goes to the other part of your double quotes, fetches the value of sum, which happens to be 12.000. Okay, so it is 12.0000000, and this will be your final output. Okay, this will be your final output, right? So the output would be sum of, okay, sum of 6.5, which is nothing but A, and okay, again B value is 5.5, E is the value which is there in sum, that is 12.000. Okay, so this is a program to a simple program to add to floating point numbers. So what I will do is that I would, in the previous program, I did not show you practically how to add to integer values, but I decided let me show how to add to floating point numbers practically using dev C++ IDE. Okay, so this is my dev C++ IDE. Okay, so let me quickly write a program, write this code. Okay, so first of all, I'll write a comment line. So I would say program to add to floating point numbers. It's a comment line ignored by the compiler. I will include the header file stdio.h because this contains the function prototype for the printf function that we are using. We have this entry point function called as the main function. Okay, so let me write the open brace and close brace, which will act as a block. So this is your main block within which I will be writing the statements needed for adding to floating point numbers. So I'm going to create three floating point variables. This is for storing the first number. B is for storing the second number, and some variable is used to store the result of A plus B. Okay, so now let me take the values into A as 5.5, F, which is a floating point value, B is equal to 6.5, F, okay, semicolon. I don't remember what was the numbers that we took during our example. So A value was 6.5 and B value was 5.5. Okay, so let me take the same example here too. 6.5 and 5.5 so that we don't run into any kind of confusions, right? So 6.5 and 5.5. Okay, so once we have assigned, these two are called as assignment statements, then let me add these two values by saying sum is equal to a plus b semicolon. As we know that every statement in a C program must terminate with a semicolon. So now I have found out the sum of, I have added these two values a plus b, and I have understood that some value is of 12.0. So let me print that on the screen and check the result. So printf, okay, so printf sum of percentage f and percentage f is percentage f, okay, followed by a corresponding to the first format specifier, b corresponding to the second format specifier, and sum corresponding to the result, that is the third format specifier. Okay, and then let me add a semicolon over here. I think my program is complete. Okay, so let me compile this program first. So go to the execute tab. Okay, click on compile. It is asking me to save my program, so I would save it as add to floats. Okay, and because it is a C program, I would save it with a .c extension. Okay, it says save as type, so I would save it as a C source file and then click on save. And as you can see, there are no errors and there are no warnings. It means my program has compiled successfully. And then let me run this program. So I'm waiting for my output. As you can see, sum of 6.5 and 5.6, 5.5 is 12.0. As you can see, we have got our result. So our program has successfully compiled and executed. Okay, so having said this, hope you learned how to add to floating point numbers. Okay, and I also learned how to do it practically, right? So in the upcoming lesson, I will also show you how to add two numbers, where two values, where one value would be of floating point type, the other value would be of integer type, and we'll see how it actually works, right? So hope you enjoyed this lesson. If you like this lesson, so please don't forget to like this video. Also don't forget to subscribe to my channel and click on the bell icon so that you don't miss out on any of my updates on this series. Okay, so meet you in the next lesson. Until then, take care. Bye bye. Love you all so much.